Hi guys, another day, another video and another new dataset. So today we are going to take up the new dataset that is for diabetes, predicting diabetes given some really interesting information about the people. This dataset is taken from Kaggle as well. You can check that out from this link. I'll also link it in the description so that you guys can check that out. So basically this is taken, this data was collected and made available by National Institute of Diabetes and Digestive and Kidney Disease as part of the Prima Indian Diabetes database. Several constraints were placed on the selection of these instances from a larger database. In particular, all patients here belong to the Prima Indian heritage subgroup of Native Americans and are females of ages 21 and above. We'll be using Python and some other packages to understand how it works. So first thing first, we are going to import the modules, loading the data into a pandas data frame. Next thing, just checking the head, few rows from the top. As you can see, we have pregnancies, glucose level, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. Outcome is nothing but the person has diabetes or not. The pregnancy column looks a bit off to me. I don't know, like there is a 6 and 8 here. I don't know. Okay, moving on. Next, I checked out the diabetes DF info. So as you can see here, we got BMI and diabetes pedigree function float. Rest of the things are integer. No missing values, as you can see. 768 rows present in the data set. Not much. Okay, we are going to deal with this much, but let's see how well we can perform with the data. Next thing, checking the correlation. As you can see, the lighter, on the red side, this has higher correlation. As you can see, these are ones because these are the same things: pregnancy, pregnancy, glucose, glucose. But what about the other shades like age? If age is more, they're like age and pregnancy are highly correlated. 0.54 means more age, there can be more pregnancy, number of pregnancies can be more. Again, like glucose level and outcomes are also highly correlated because of course in diabetes there can be high level of glucose in the blood. I think in type 1 or type 2, I don't remember, but yeah, there is a certain type of diabetes where the glucose sugar level will be higher than normal. Next thing that I checked is pair plot because it's fairly small data set, so it was possible to check that out. So you can see the last one will not make a lot of sense because outcome is just 0 and 1. We got in both range a lot of data, but as you can see, BMI here, these are kind of constant things. There is not a clear relationship visible as I can see. Next thing that I did is splitting the data into training and test set. I just listed out the classification models because at the time when I actually worked on this dataset, I have just started with the classification tutorial videos, so I just wrote it down like what are the things I am going to check, or maybe I'll use some of them. First thing first, logistic regression. Most most important thing here, scaling is not required for logistic regression. I didn't know at that moment when I was doing this, but yeah, it's not required. Next thing, evaluating 75%. Great. Next, decision tree classifier. It's taken from scikit-learn.tree. So classifier 75%. Next we got random forest classifier 74%. Not that great at all. I think I need to work further on this dataset. Let's see. Maybe we can get rid of some of the features that can be helpful for getting a good result. We have to try that out.